Hi everyone, so this talk is about mutation testing. So I specifically invited some testers to come along, and it's nice to see that they're not here. So, so this isn't necessarily a language-specific talk. It should be language agnostic. However, for the purpose of this talk, I decided to use Infection, which is a PHP framework for mutation testing. So if you are wanting to go away and use this, the core of the talk is about mutation testing itself, and then the examples are all in PHP, and you can go away and do some of the exercises yourself if you wish. So the boring bits first. So if you were at the last PHP event, Mike had about 10 slides of all his achievements and accomplishments, and I don't have any. So I'm Adam. I'm a consultant engineer at Armakuni. I put in my Twitter there, but I wouldn't bother following myself. I don't really tweet anything interesting. So I work at Armakuni, who's based in London, and they've worked with some well-known brands, and their sort of main concept is improving a company's software development process. So I don't want to do a sort of shameless plug, but we are also recruiting. And if you're interested in doing things like this, like with talks, and you're going around and helping companies sort of get better, let me know, because there's a really big referral fee. So I'm more than happy to refer any of you with any skills. So first of all, code coverage. I'm not sure how interactive the audience is going to be, but who here uses code coverage, has heard of code coverage? What? Oh, that's pretty good. Okay, so I'm going to bore you all then, the people that already know what it is, because I'm going to talk about it. So code coverage is a useful tool that we use to monitor and report on our automated unit tests. So what this is useful for is it highlights aspects of code which may not yet be adequately tested. So say you've missed a part, you've thought that everything in your files are fully tested, and it can highlight something that's not tested, and we can use that as a metric to kind of gauge whether or not we have enough testing in place throughout the application in its entirety. And then we can also use that to maintain test quality over the life cycle of a project. So if you're using CI/CD pipelines, it's a good tool that you can use to sort of gauge a decent quality suite. So just to dive into that a little bit further, this is what a sort of standard code coverage report would look like. So this is what you're getting back after you've ran your code coverage, and the green is sort of representing good. I mean, it's kind of a bit of a false positive because you've got your little percentages there, but green is generally good, yellow is kind of okay, and then red is you've probably forgotten to do anything at all. So my warning over this is that you can obsess over it. So it's quite common for companies to put down an arbitrary value of this is what you're supposed to hit for code coverage. So let's say a company will say, okay, let's get 80%, let's get 90%. And this is a common thing for companies to kind of say, this proves that we have a good knowledge of our tests and how well they're being run. And you can obsess over this. So I get very sort of OCD about every single line being green and every single thing saying 100%. So it's quite easy. So this represents, the report represents a kind of an exact replication of your application structure. So this isn't mine, I've just taken it off the internet. So if it looks terrible, it's not mine. So it should, basically you get this interactive web page where you can click into each one and you can go down file by file. Again, this isn't my code, so if it's terrible PHP, I apologize. So what it's doing here is you're basically getting the highlighted parts in green are what is completely covered. The bits that are in red, you've completely missed. So this can highlight to you that the tests that you've got in place, although they're testing the core functionality, in this case, they're not testing everything, right? So you can use this and you can go back and you can add some more tests in order to up that coverage. But does anyone know, or is anyone familiar as to why code coverage isn't perfect? So this is kind of like an open question, but I'm not really expecting an answer. So what I was hoping to do here is to ask the testers, but obviously, they haven't arrived. So the problem with code coverage is, like I sort of said earlier, it can just be an arbitrary value. Even if you've got 100% coverage, it doesn't necessarily mean that you have good tests. It means that you know how to write tests for the purpose of code coverage. So code coverage can quite easily be gamed. So this might look like a confusing image here, right? But if you imagine that this is your code coverage, so this is basically saying that you can cook an egg and that your code coverage is 100% covered that. So you've got a pan that's, saucepan, it's working as intended according to your tests. You've got an egg, it's supposed to crack open and it works. You've got the actual egg itself, and you've got the sort of the hob. They're all working in isolation, but nothing is actually working as you're sort of saying, and there's nothing that's telling you that is the case. So basically, high code coverage doesn't guarantee test quality. All it guarantees is that you've covered lines of code within your tests. So if only there was some way that we could combat that, and we could provide a little bit more quality and validate our tests a little bit further. So here I would ask my faithful tester, and I would say, before I sort of explain what mutation testing is, I would ask my tester, what would you do as a tester in order to try and test some functionality and prove that it's working as it should? And I was hoping that the answer that I would get from that is that they would try and break it. So essentially that's what mutation testing is. Mutation testing is trying to break your code in order to force your tests to fail. So this proves whether or not your tests are actually valid or are actually saying that they're doing what they're saying. Do we have many people that know what mutation testing is, that have used it before? That's nobody in the room, which is great. So now I can say anything and no one can tell me otherwise, right? So, okay, so mutation testing, it highlights how good your tests actually are, and it forces the creation of valuable tests. So the purpose of what that's doing is it's changing individual bits of code for the purpose of your tests to say, this should break my test, therefore your test is doing what you're saying it's doing. So the idea of that, again, is similar to the coverage report. We can use these in conjunction, so we can provide an additional quality gate, and then in your CI/CD pipelines you can have your code coverage and you can have your mutation tests running sort of one after another, and then your mutation tests are going a bit more further in detail to the quality of the actual tests as opposed to the coverage. So the framework that I chose for this one was the top hit in Google for PHP mutation testing, and it is called Infection, which I quite like. I quite like the mutation and infection. So basically, I've narrowed down the sort of three core principles of what Infection says according to its documents that it's doing. So it runs the test suite to see if all of them pass. So you can't have you can't run the unit tests if your tests are failing. So you need all your tests to pass, and then it will run the infections on them. And then it's mutating the source code with a set of predefined mutators. So this is taken literally from the documents, and it kind of can be a little bit scary because it's saying it's mutating the source code, and it's not actually doing that. It's mutating sort of byte code. So you won't actually go into your application and it's stopped halfway through and some of your variables have changed to something else. So what it does is this analyzes whether or not the tests start to fail. So as I've kind of said before, it wants your tests to fail. So this can be sort of quite a strange concept, especially once we start talking about the terminologies here. So this is a mutation report example. It's kind of similar to the reports that you're getting for the code coverage. However, naturally, the one framework that I picked for PHP didn't have a nice dashboard to show for the purpose of this talk. So it's all done in the CLI. So this is very much what you could have had if you were using a different language. Not that I'm trying to plug that in this talk, but again, this is showing sort of the exact same thing as what you're expecting to see in the code coverage, which is going down each particular file in your application structure. And then the interesting bits that we care about are these things here where it's killed and survived. So it sounds a bit sort of last resort, but we want them to be killed. We don't want our tests to survive. So if they're surviving, that means that the mutation has gone through, it has changed a line in your code, and your test still thinks that it's fine. So if we look into that again, you can click into each one and you can get a bit of more of an understanding of which mutation was happening at what particular time. So as you can see at the top here, this is test.php. So this is an example of a very simple mutation. So each mutator is changing one specific bit. So here it's specifically changing this plus sign to a minus. So our test would test something like when you call the add function, it should return a plus b. But it's going to change that to a minus, so then your test should fail, and that will be a successful mutation result. So what that looks like in infection, I took a sort of screenshot of this part because this is as like fancy as you're going to get. So this is still very nice. It still does exactly the same thing. You don't get this sort of HTML interaction. There might be other PHP mutation frameworks out there that can do this. It's possible that this can even do it, but I couldn't find it if that's the case. So you run your mutation tests, it goes through, it takes a little while, it's quite fast. So the sort of concept of mutation testing has been around, as far as I'm aware, it's been around for like 30 years. It's not like a new concept, but we've never really had the technology to do it as easily as we can now. So now there are all these frameworks, and it's not actually that common that people know about what mutation testing is. But I'm hoping anyway from this talk you'll look and you'll see, oh well, actually that's quite interesting. I've never sort of thought about that before, and maybe go away and use it. And that's exactly what happened with me. So this is basically the example of the report that you're getting. So these full stops are representing good, and in terms of infection refers to the survived as escapees. So basically here it's saying that we've done 64 mutations, 49 were killed, and the rest of the mutants managed to escape, which again I find quite funny. So it's then giving you what your metrics again. So built into infection is also code coverage if you wanted to use it. So it has its own. For the purpose of this talk and sort of what I was going on with to talk about later, I'm using PHP unit. So I'm using PHP unit combined with infection, but you can do pretty much what PHP unit coverage is doing within infection yourself. So at the bottom, it's giving you your metrics here to say this is sort of how well you've done. And the idea from that is you look at what your mutants, your escapee mutants are doing, and you go and improve your tests based on that. So this is sort of another example of a mutant, but this one is taken directly from infection this time. So believe it or not, like I wrote at the bottom here, like I apologize if it makes your eyes bleed, but it was, you just get a standard notepad file. So I have added these red and green lines. So you literally got nothing in this. So it would be nice if any of you fancy going and making a UI for it. That would be quite good. So again, all this is telling you is it's changed this value where it's expecting to do -1 and it's changed it to -0. And then this is an example of when I've changed that, you know, the test is still passed. So you need to go and change your tests. So going on from that then, so what can we do with that? Has anyone had has anyone came across a code base where you've had no tests in place? And is that a common thing in PHP that you come across? I imagine it probably would be. I mean, it is sort of across the board, but so what do you do then? What do you do when you've got a code base where you've got no tests? So you run, right? So it's quite easy for you to sort of think, okay, this is the end of the world. I don't really want to get off here, but I'm going to sort of go through a technique where we're going to combine everything and see if it's a good way for you to approach what you would do if you came across such an example. So here is some typical PHP code. So like in my notes here, I've got pause for laughter, because so this it's meant to be bad, right? This is meant to be bad. So this is a code kata called the Gilded Rose. And the idea of this is a refactor code kata. And if you're not familiar with the Gilded Rose, it is to do with World of Warcraft. So if we have any World of Warcraft enthusiasts in here. So there is an inn called the Gilded Rose somewhere in the World of Warcraft. And the purpose of this is you are selling some goods within that inn, and you need to refactor. So you'll see some of the items, and if you're familiar with World of Warcraft, you'll probably understand what the items are. So as part of this, if anyone really wanted to, I'm not saying that you have to, but this was going to be my live demo part, and I decided that I wasn't brave enough to do a live demo part. So we do actually have a repo there, so you can go down, you can get the repo, and you can do it yourself. So some of the things that I've done, I've probably not done it in very nice PHP fashion, but I've provided some sort of getting started things there. So mutation testing is already inbuilt, code coverage is already inbuilt. So if you just wanted to go in and just start from scratch with this horrible code, you can. And there's also some sort of guidelines to help you in order to progress, but it'd be interesting to see how you refactored this. It's not very long, it won't take you all that long. So if you wanted to do that, give mutation testing and coverage testing a try, by all means. The link will be provided again at the end if you want it. So what we can do is we can use code coverage to help us test our core functionality. So it's quite common. I don't know if it's the same in the PHP world, but generally there's a bit of a void between testers and developers. So here again is where I'd come up to my testers and say, here's where they can add value to this, right? So here what you're doing is you're looking down what the actual code is, and then you're going to start writing some tests to cover the core functionality. And the core functionality testing is kind of what acceptance testing is. So you could go through that with your testers, you could go through that with, say for example, project managers, something like that, and you can decipher if what your tests are doing are what the application should be doing. So what this is useful for is once you've started your testing, you can kind of see here the coverage is starting to go, okay, so we've added one test here. We're starting to see where the functionality is missing and where we need to sort of focus on more. And then I apologize again if this is terrible PHP code, but this is me writing unit tests. So basically here I've added 2 unit tests, and they pass into 2 different items, and then we test to see what those sort of outcomes are, and we're expecting certain mathematical things to be done to the quality and to the cell-in. So then, as you can see, as we're going on, we're starting to cover more and more aspects of code. Again, I should reiterate this, this doesn't necessarily mean that everything that we've got tested is brilliant, but we're getting a baseline here for something where we started with 0. So as we keep adding tests to it and we build it up, we get the magic 100%, and that's everything done, right? We're up to 100%, everything's covered. So no, that's not right. But what this does give us is this gives us our baseline to talk again to our project managers or anyone that else that needs to be involved. It could just be ourselves, but it gives us that baseline. It gives us like a security blanket of this coverage is actually letting us make sure that these aspects are tested, and that when we change the code around, those tests should still pass, and that allows us to progress further on. So are people familiar with test-driven development? Is that a common practice? So I think the idea of this slide, I stole it from someone else, but I'm kind of meant to go around the room here, and people are meant to be red, green, but I'm not going to do that. So the idea of it is you start with a broken test, you make that test pass, then you refactor your code so that the test is then broken and sort of continue on. And although this is technically this sort of concept that I'm teaching you now is sort of test after development, the idea is that the test-driven development is allowing you to focus how much you then refactor. So the next part is, so this might seem like madness here, but what I'm doing here is literally copying and pasting the entire section into a new section. So at the top here, we've got the if item names aged brie, and then in the else is everything else that was in the code to exist. And although that seems like madness, but what we can actually do is we can paste all of that code again into the if statement, and then we can use the code coverage to say, here's the bits that you don't need. So we can then go in and delete all these red bits because we know that our tests have proved that that will still be fine. So we can get rid of those, and then we can start refactoring, and we've still got that baseline security net of your coverage tests. So you can go into that with as much detail as you want. You can keep diving down into that more and more, and it's really up to you. So for me, as just part of this, I just did it to kind of proof of concept, but if you want to go away and then sort of deep dive more into this, it'd be interesting to see how sort of minified you can get this stuff and how nice you can get it. So the idea after that is that you provide confidence with your mutation testing. So you've got your baseline with your coverage, and then the next step is the mutation tests. So the mutation tests will allow you to sort of say, okay, well, what if I change this specific value? Your tests are all still fine, your coverage is still fine, but we want to test these individual values, make sure that your tests are that fine-grained. So then you can write more tests and take that test-driven development approach to then refactor and go even more in further detail. So on top of that, so this is basically, I just drew this myself. Well, this is a very rudimentary example of a CI/CD pipeline. So the idea of this is just focusing that we've added the mutation testing onto the end. So a typical sort of deployment strategy would be, you've committed something, it goes through some kind of code quality gate. So like if you've got like linting, something like that. And then you've got your automated unit tests, which should all pass, and then your coverage should tell you how good your coverage is, so you could have a quality gate for that. And then again, you've got your mutation testing, where realistically, you could probably have something like, I should have no surviving mutants. So again, I keep going back to my testers. I'm sort of worried about time. It's like, am I taking too long? Am I going too quick? I've got not many slides left, so if I should talk slowly, then let me know. As in, this is pretty much my last slide. So this doesn't mean that we can get rid of manual testing. So here I found like a tester and a developer. So all we're doing here, right, is we're still best of friends as far as anyone cares, right? So on the face of it, we're best of friends, and what we're doing is we're allowing the testers. We're not getting rid of them, but we're allowing them to do what they should be doing, which is exploring, trying to break things, trying to do things that you shouldn't have already thought of. They shouldn't be testing the individual sort of functionality of your code, which should already be done. So in summary here, if you wanted to take anything away, it's write good tests. That's literally all I've told you to do here. So if you write good tests, then you don't need to care about any of the tools that I've just sort of told you about. But all I've given you is some things that can help you get a little bit better with that. So there are tools available such as code coverage, such as mutation testing, that can improve the overall quality of your tests. But at the end of the day, if you write good tests anyway, the rest will follow. So one good takeaway is write good tests, and that's me.
Great,
Thanks.
thank you, Adam.